Well, hey, everybody. I'm here to talk about a little bit of a journey that Microsoft's been on. We're a company now that, I would say, we really love open source. We're a big contributor to open source. But we certainly haven't always been this company. I think if you were to look at us 15 or 20 years ago, if you were polite, you would say that we were skeptics. But there's been a bit of a change that's happened for us. So part of what I want to talk about today is how that change happened and how we got here. And furthermore, how we got here. I mean, here's a dinner with Linus, the creator of the Linux operating system, Dave Cutler, the architect of the Windows NT operating system, the other big popular operating system, with Bill Gates, having dinner at Mark Rusanovich's house. How did we get here? Like chummy. And it's a journey that's been going on for a long time. The first big change for us was in 2009 with a contribution of about 20,000 lines of code to the Linux kernel. And that was probably the moment for us as a company where we began to think, there's a way to make this work. There's a way for us to really start to collaborate and contribute to some of these open source projects. By the time we got to 2015, we had released Visual Studio Code, which was a free open source code editor, which turned out to be one of the most popular code editors around. And in 2018, we acquired GitHub, which at that point had 28 million developers and about 85 million repositories, and has continued to just grow like crazy, and now has over 518 million projects hosted in that system. So it's been something that we've been working on for quite a bit of time. And our company has been leaning in harder, not just on these projects, but in a variety of other projects. We're now the leading cloud contributor to the CNCF, and the number 2 overall contributor to the CNCF for the last 3 years. And we contribute to a variety of different types of projects. These projects are critical not only for how we operate our services, but providing those kinds of open source solutions to our customers. Today at Microsoft, over 2/3 of all virtual machines that are running inside of Azure are running with Linux. And that Linux operating system powers some of our biggest workloads. Workloads I'll talk a little bit more about in just a couple of slides, but workloads that are foundational for Microsoft 365, as well as OpenAI's workloads. And we continue to be even more committed to open source than before. We have this simple philosophy that we contribute upstream first, and then we take those innovations and bring them downstream into our own products. And for us, security continues to be a really critical part of how we think about open source going forward. We have a number of new projects that we've created, we'll talk about later, called Copacetic, Dalec. We have our own SBOM tool. These are all open source projects that we're hoping to build community around because we think they're really useful. There's things that we've discovered as we've been running at scale. We also have a deep partnership with the Rust Foundation, with Alpha Omega, with the OpenSSF Foundation in general. And we do that because we think it improves the security for all of us as a community. So the first workload I want to talk about is something called Cosmic. Think about Cosmic as the entire container platform, the developer platform for everybody who builds an Office service at Microsoft. This is the foundational system for Exchange, for Teams, for Office, and it runs on millions of cores, all of it on AKS, all of it on Kubernetes. And it makes it one of the largest Kubernetes clusters in the world. That system bakes in a variety of different guardrails for our software developers, making sure that we can operate at gigantic scale without it being incredibly expensive for us from an operations point of view. And it's all built on top of open source. It uses Kata for autoscaling, and it uses Prometheus and Grafana for monitoring. So foundational service, one of our most important businesses, running on top of Kubernetes and AKS. ChatGPT is another service that runs on top of AKS, and it's a gigantic workload. There are over 500 million weekly users of ChatGPT, and that entire service is built on top of the same kinds of Azure services that anybody can use. Our Azure GPU services, Cosmos DB, AKS, Postgres, Azure Storage. All of these are services that are available to everyone. Many of them are open source projects, and they're used to be able to run this gigantic service. And what's interesting about it is OpenAI only has about 12 people that are responsible for administering that Kubernetes system. And how do you do that? Like, how do you scale an app to over 10 million cores with only a dozen engineers? At the center of that is AKS, of course, built on top of the Kubernetes project. And AKS provides a number of additional services that provide things like automated deployments, automated healing, automated patching, and built-in safety. But you can also take it further. If you can deploy your cluster just to a single region, or with Fleet Manager, you can use new features that make it easy to deploy your clusters anywhere in the world using standard policy and standard operational models so that that service will scale to dozens of regions without you having to scale your engineering team, your operations team in the same kind of way. Now, as we've been building these big services, running these gigantic workloads, there are a bunch of things that we realized were missing. And we've taken those things and turned them into open source projects. And we hope that they're interesting open source projects. We hope that you might choose to contribute to some of these open source projects, or at least tell us what you like or don't like about these kinds of services. One of them is Dapper. Dapper is a CNCF project that's designed to make it easier for application developers to build these complex distributed apps without having to understand all the nuances of the individual components that make up those apps. So you can abstract away things like pub sub queues or secret stores. Radius is a project that was designed at the same time that we were designing Dapper. And Radius is designed to make it easier for application developers and the platform engineering teams that support those developers to collaborate together on building cloud-native apps. And it's designed to put the application at the center of that collaboration. Instead of us being very focused on the infrastructure, how about we really step back and think about what's the app that we're trying to build? A couple of security projects we built are projects like Copacetic and Dalec. Copacetic is a container patching tool, and it's based on the idea that you might build a container image, and maybe you haven't patched everything in that image. Like, you've done your best, but we can miss things. Copacetic runs as part of your build pipeline. So after you build the container image, you hand it off to Copacetic. It scans that container image using Trivy, identifies any vulnerabilities that haven't been patched, downloads them, creates a new layer in that OCI image, and then that's what you push to your container registry. That's what gets pushed into production. So it catches it on its way through. Because a lot of times saying that we're going to shift left means we're just putting more work on developers, and we sometimes miss things as developers. So this will catch some of those errors before they go into production. Dalec is another project that we use inside of Microsoft. It's the tool that we use internally to have a declarative way to build operating system images and container images, to rebuild them for our own use. And again, it's another open source project that we hope you'll take advantage of as well. We've also built some interesting projects that are trying to change the way that we think about change processing or event processing. And one of these projects is called Drassy. Drassy is designed to make it easy for you to write a query that says, here's the kind of event I'm looking for. And if you see it, call this code. And so instead of having to process every single event that gets pushed through a data pipeline, you only have to process the ones that you care about. SBOMs are incredibly important for all of us. They're going to be incredibly important, even more so, as CRA requirements begin to come into effect. And the SBOM tool that we use inside of Microsoft for our build pipelines is actually open source, and it's an open source project that we hope that you'll take advantage of as well. It can generate SBOM for you in the SPDX format. We've also open source projects like Semantic Kernel and Phi, which are open source projects designed to help with building AI applications. We hope you'll take a look at those as well. So I hope this talk has helped everyone understand not only why we love open source so much, but how it's something that we're going to continue to work on. Critical workloads at Microsoft run on top of open source. We continue to contribute to the open source, not only with established projects like Kubernetes or Linux, but with new projects like Radius, Dalec, and Phi. And finally, we know that this is a journey. We started in 2009 with those early Linux contributions. But we know that we're going to continue to learn as we continue to increase our contributions, both to open source and to the broader open source community. So with that, thank you for coming to this talk.